Hi, this problem is to cover problems 8 and 9 on graphing rational functions on the Honors Test 3 test review. So if we take a look at number 8, we've got a rational function, and probably the very first thing we should do is recognize that we need to factor, because that's going to help us find wholes and asymptotes and all the other good stuff we have to find. Well, if you take a look at 8, what you notice is in our numerator, all of our coefficients here are even. So that should tell us that we need to factor out a2. If we do that, then we end up with x squared plus 5x plus 4. After that, we should recognize that this trinomial can actually be factored into two binomial factors, x plus 4 and x plus 1. Our denominator, x squared plus 4x, has a common factor of x, and when I factor that out, I get x plus 4. So probably one of the very first things we should do is recognize that after it's factored, we have some factors that will cancel out. And in fact, we can cancel out the quantity x plus 4. Recall that if your factor cancels out for that restricted value in your denominator only, that means that we will have a whole here at this canceled factor. So in this case, that would be negative 4. So we need to state that we would have a whole at x equals negative 4. Remember, you set the factor itself equal to 0 and solve. That restricted value is where the whole will be. We should also recognize that where the factor does not cancel, in this case x, is where we'll have the vertical asymptote when we set that factor equal to 0. There's nothing to solve, but if there were, then we would solve it. So we have a vertical asymptote here at x equals 0. Next, we remember, hopefully, our mnemonics for horizontal asymptote. We need to remember Bobo. If our exponent is bigger on the bottom, we have a horizontal asymptote at y equals 0. If it's bigger on the top, Boton, then we have no horizontal asymptote. And then eats DC, where if our exponents are the same, we divide the leading coefficients to get our horizontal asymptote. So when we evaluate that, we always look back at our original function, and we have 2x squared over x squared. So because our exponents are the same, we're going to divide the leading coefficients. So I'm going to circle those here, meaning I'm circling an understood 1 there. So we're going to have a horizontal asymptote at y equals 2. Please keep in mind you must put the x equals or the y equals for these equations for the asymptotes. If you put negative 4, it's wrong. If you put 2, it's wrong. You have to put the x equals negative 4, and it's always x equals for vertical, but it's always y equals for horizontal. If you have a horizontal asymptote, then you do not have a slant asymptote, so we can put none. Next, we have to look for our zeros. Our zeros come from our surviving factors up top. So surviving meaning it didn't get canceled out. So we do not have a 0 at negative 4. That's where the whole is. We can't have the graph cross the x-axis where there is a whole, meaning it doesn't exist. So we only look for the factor in our numerator that did not cancel. So if we were to set x plus 1 equal to 0, we would have negative 1. So we have a 0 at negative 1. Lastly, we look for our Y-intercept. So remember that your Y-intercept is a ratio of your constants. And it's best to always look at your original function. So if you think about it, up here in our numerator, we have 8 as our constant, but down here at the bottom, we don't see one at all. So that means it's at 0. We have a constant of 0. Well, if we were to divide our ratio and have 8 over 0, that would actually be undefined. We cannot divide by 0. So that means, in terms of a y-intercept, there is none. So if we graph this function, we should be able to verify all of these things that we just found. But of course, you should be finding these things without having to use your calculator first. 2x squared, always start off with parentheses. 2x squared plus 10x plus 8 divided by x squared plus 4x. If we graph it, you can see now why, you can see now why we don't have a y-intercept. We had the vertical asymptote at x equals 0. So the graph doesn't exist at all on the y-axis, so there's not going to be a y-intercept, so that should make sense. So you can see that it does appear that we would have a horizontal line at y equals 2. In fact, if you put in 2 here, I'm going to actually make that dotted, then, well, it didn't do it dotted. At y equals 2, you can see that's kind of where that horizontal asymptote should be. You can also see that you will have a restricted value at an x value of -4. That's why it says error. And you'll also have one when the x value is 0. Okay? So that should verify that your answers are correct. Next, moving on to 9, we have to list all the information, then graph it. So we'll start off the very same way that we did with problem 8, first by recognizing that we should factor. So I'm going to come down here. And by the way, this should be x squared. I apologize for that. Please make sure you put in the squared. X cubed plus 2x squared minus 8x over x squared minus 4. The first thing you should recognize is that all of these terms have a common factor of x. So I'm going to factor that out. So that would leave me with x squared plus 2x minus 8. Then, because this is a trinomial, I'm going to try to factor into 2 binomial factors. And we should be able to use x plus 4 and x minus 2, because 4 times -2 is -8, yet 4x minus 2x gives us 2x. Moving on to our denominator, this is a difference of squares, which factors into the quantities x plus 2 and x minus 2. So now it's completely factored. Now we can begin finding our wholes by first recognizing that the factors x plus 2 would cancel out. So therefore we would have a whole at x equals positive 2. So remember we said x minus 2 equal to 0 when solved. Our vertical asymptote, remember vertical asymptotes, you always look at the denominator. Same for wholes, you only look at the denominator. We have x plus 2 surviving. If we set x plus 2 equal to 0, we would have an x-intercept, or a vertical asymptote rather, at x equals -2. For horizontal asymptote, we'd want to look here at our the degree of the leading terms. We have x cubed over x squared. Going back to our mnemonics, if it's bigger on the top, we have none. So we have no horizontal asymptotes. But remember, the rule is if you have a degree on the top one higher than the degree on the bottom, then you are going to have a slant asymptote, which means we're going to have to do some division. But before we move on to that, I'm going to go ahead and do zeros and find the y-intercept. So remember, zeros we find by looking at our numerator for zeros. So the factors that did not cancel. So if we set x equal to 0 and x plus 4 equal to 0, we would have x-intercepts at 0 and at -4. But don't put parentheses. If you put parentheses, it'll look like an ordered pair. It would be okay, however, to write 0, 0, or, and then -4, 0. So those are our zeros. Looking at our y-intercept, if we, remember we have to look at the ratio of our constant. So our constant up here is 0. Down here it's at -4. So if our y-intercept would be 0 over -4, which would equal 0. So we have a y-intercept at 0, 0, meaning it's hitting the origin. Okay? Next, moving on to our slant asymptote. I'm going to do this on a separate sheet of paper real quick. We want to do division. So what we want to do is always use our original polynomial, x squared, plus, in this case, we don't have a linear term, so we would need plus 0x minus 4 into x cubed plus 2x squared minus 8x plus 0. So when we divide this, remember we take our leading term in our dividend, and divide by the leading term in our divisor. So x cubed divided by x squared is x to the first power. I'm going to line that up over my linear term, and then I'm going to distribute. X times x squared is x cubed. X times 0x is 0x squared. X times negative 4 is negative 4x. Change my signs, and I'm going to have 2x squared minus 4x plus 0. Again, starting the process over, I take my this leading term here, 2x squared, and divide by x squared, and I get positive 2. So I'm going to put my positive 2 up here over my constant 0 and multiply. 2x squared plus 0x minus 8. Draw my lines, change my signs, and really the remainder is negligible. We don't even need it. So this is actually the equation of our slant asymptote. So really what you need to remember is that once you get your linear and constant term, you are done. So now we've found all of the characteristics we need in order to graph it. So let's see if all this makes sense before we graph it by typing it in our calculator. So we've got x to the third plus 2x squared minus 8x divided by x squared minus 4. All right, so let's see. It does appear to have a vertical asymptote at negative 2. I'm sorry, let me remove this right here. So it did appear to have a vertical asymptote at negative 2. It did cross at the origin, which would have been our y-intercept, and our zeros are at 0 and negative 4, so it looks pretty good. Now, if you forgot how to graph x plus 2 for your slant asymptote, which you must do, remember that this means you have a y-intercept of 2 and a slope of 1, so you go up 1 over 1. But if you had to, you could graph it and get ordered pairs from your table looking over here at your y2s. So to get started, I'm going to put in our vertical asymptote at negative 2. I suggest you use a highlighter or a different colored pen or something to help denote the asymptotes from your graph and make sure they're dotted. Our slant asymptote, I'm going to start at positive 2. We go up 1 over 1 because it has a slope of 1. So this would be my slant asymptote. I know that it will cross the graph at the origin and at negative 4. At that point, to create my function, I simply want to make sure I hug my asymptotes. I'm approaching but not crossing these asymptotes here. And that is it. I hope that helps. Feel free to pause it, go back and rewatch all you need to. Good luck on your test. My mouse is gone. I can't stop it. My mouse is gone. I can't. Where's my mouse? All right. I don't know what that means. Can I just get a mouse? I am not trying to have to re-record all that again. I did an awesome job. I don't know how to stop the recording.
Isn't that like a command, whatever?
I don't know if it's still recording or not. The screen thing box it down here, but I can't get to it. That was perfect time. Oh, there it is. Yay. I decided to come back.